So hey one here. In this video, what we are gonna do is that we are gonna look into this problem that is what merge sorted array. But we are not gonna directly jump into this what the problem is and also stuff. We'll be understanding that why I need to solve this problem. It's not just that we because with this way we can just solve the thousands of problem, which is not a good thing. So I need to come up with why I'm solving it, what a pattern I'm understanding, and also stuff. We'll be looking into all the thing patterns and also stuff. But before that, I wanna explain you that what's the problem statement is. So here, what is given to us? As our nums1 array, we will see carefully. Nums1 which has m elements. M elements in means what? There's let's say here m is equal to 3. That means what? There is 3 elements from the starting that belongs to the nums1 array. That means what? Here 1, 2, 3. That's the actual elements belongs to this nums1 array. That what it says to us. That means first m elements are valid, rest are zeros that are placeholders. For what that placeholders is, we'll be looking into that. And here others are nums2. Here nums2, let's say the size of nums2 is n, that is the 3. And what does it says to us? That is there is 3 elements in it that belongs to nums2. Here it's what? 2, 5, 6. Okay, good to go. Now let's quickly go through what the problem statement is. Okay, so here what is given to us? Two integers nums1, nums2 sorted in non-decreasing order. We need to carefully see this non-decreasing order. So yeah, let's say let's have a look at this. What's this? This is the input that is given to us. Let's write it down. This is the input that is how in this case. Okay, no worries. So now here m is the size of nums1 array, and n is the size of the nums2 array. Cool, great, no worries. Now what I want to do is that I want to short this both array. Here is that I want to merge nums1 and nums2 into a single array sorted in non-decreasing order. So the thing which you need to consider, which you need to understand is that both array is already sorted 1, 2, 3. As you can see, these both are already sorted over in this case. So that's the thing that has I need to be keep in mind. Here 2, 5, 6 is already sorted. That is in the non-decreasing order. That is smaller elements, then bigger elements, then bigger elements tend to it would be the right at the right side of it, something like that. So here is what that is the point that I have is that both arrays are already sorted. Okay, great, no worries. And now I need to do what? The final sorted array should not be returned by the function. I don't want to return after merging all these things. Here I need to do something. What that thing that I need to do is that here is that I need to store that thing inside in nums1 itself. I said in the start that is it is the left kept a blank, that is a placeholder. So in the future itself I'll be placing the elements where which elements has to be here after the merge, that is here 3, 5, 6 has to be here. That will be defining how and all this afterwards. And to accommodate this, nums1 has a length of m plus n. That's the reason which for the question which I said at the start. Where the first m elements denote the element that should be merged, and the last n elements are set to 0 and should be ignored at the start. But this is the placeholder. I want to use it. So afterwards, I can keep the elements which has to be here, that is at its correct position. And then to change the entire array if needed. Just like here, let's say 3. 3 is not its exact current position where it has to be. If you say carefully, at the third position, that is at index 2. Now the element 2 is there. We'll look into that how and what it is. So here if we'll see, that is what I need to do is that final array I need to return, that is also in this sorted manner 1, 2, 2, 3, 5, 6, something like this. And also all these things, let me write it down. What I want to do is that I want what final array to be sorted. And also what it all these things has to be done in place. I don't want to use any additional um array or any kind of space that I want to go with. Okay, that is it is what I want to achieve over in this case. Great. No worries, we'll look into that how we can do that. So this is the problem statement that is given to us, and we also come to know that what I want to actually do. So yeah, before jumping into the solution and all the stuff, let's look into it. That what's the problem statement, what is given to us, what I want to do, and all the stuff. So what's the very first approach? That is the brute force approach. The very first thought that comes to our mind is what? Let's go with the brute force one first, and then we'll look about the rest of the afterwards while doing it. So the brute force uh, is what, that is the, with this mindset, what's the most obvious way in this case is that I'll be doing what? I'll be creating a new array, let's say, and I will, in that new array, what I'll be doing? I'll be taking all the elements from nums1 and nums2 from both the arrays, and what I'll be doing is that I'll be shorting it, and then because I don't want to return the another array, I need to return the nums1 itself, so I'll be copying back entire things in nums1 itself. That's what I'm gonna do. So what the code that you'll be writing for this? So let me explain it properly. So what is given to us, that is the array is here, what array is, let's say here is, you see that the array is this. Great, no worries, let me place it here. So this is the array which I does here. So what I am saying is that if this is the array which I does here, I'll be taking elements from both. What is the elements? 1, 2, 3, and what else? 0, 0, 0 is not, that is the placeholder, because m is what, m is here is what, m is just 3, so I just need to take the 3 elements from the start. Okay, no worries. So 1, 2, 3 from nums1, 2, 5, 6 from the nums2. That's what I did, is that I took the elements from both the array. Now I need to short it. Great, no worries, let's short it. So what I'll be doing, so after sorting, what will it be? It will be 1, 2, 2, 3, 5, 6. Okay, but here this thing, this thing is what, this thing is in some another array sorted. I don't want to return this, so I want to return nums1, so I'll be copying this entire thing in nums1. That what I'll be doing, that is what I'll copy this in nums1. That's what I'll be doing with this approach. But here, if you'll see carefully, what I'm doing is what, here I am writing what, here I'm, firstly, the very first thing I go wrong is that what, I took another array of size what, m plus n, because I want to return the merged sorted array, because the m is the size of the nums1 and n is the size of the nums2. And for what I did is that I iterated over putting the I pointer all the m elements in the nums1. And what I did in that particular iteration is that in the temp ith pointing elements index, in that temp array, what I place is that whatever the nums1 element, nums1 array element I just have pointed by the I. And same I did think, I did the same thing for the nums2 as well, with j pointer going from 0 till less than n, because n is the number of elements for the nums2. And what I did is what, so now m elements is done. Now I'm gonna go with the m plus jth element, so that I'll be going with this over here in this case, and then I'll be placing all the element that is pointed by the j in the nums2 array. And at the end, I'll be doing what, shorting it, this temp array, and then copying this entire array in nums, using some inbuilt functions or iteration or what or whatnot in nums1, because I want to return nums1. I don't want to return nums1. Nums1 will be getting fetched by the function itself. I don't want to return it explicitly. That's what I'm going to do in this case. So, but if you see carefully, what is here? Let's analyze it properly. So here I have created what? Uh, Another array, temp array. So this will be taking some space, and what that space is m plus n. That is m number of elements and n number of elements. So it says what, bro? I can do all this thing, but you would be requiring what? You need to pay what in terms of the complexity, that is space complexity over you. That will be what over here in this case? That will be big of m plus n. And also, if you see carefully, what is there? I have iterated over what this thing. All the m elements from the nums1 and all the n elements and the nums2, and I've placed all this thing in temp array, which I've created, that is the extra space, and I'm shorting it. Whatever the algorithm you're going to use sorting it, let's say yeah, I've used the inbuilt function. So internally it will be shorting it. So that will be taking log of n. N could be the number of elements that it could be, and here the number of elements is what? M plus n. M plus n elements I'm comparing, I'm shorting, and I'm comparing each element with m plus n elements for shorting. That will be what? Number of elements into log of number of elements. That is, I'm comparing m plus n elements with m plus n element each time in iteration nested wide. So here the log m plus n into log of m plus n, that is the time complexity required for this thing that I'll be going with. So here it's what? Time complexity will be what? Here in this case, it will be big O of what it is, m plus n into log of m plus n, which is not a good thing. Why? See, because if you see carefully, what is given to us is that both arrays are already shorted. I could leverage it, na? Why I'm shorting it again? With this much of complexities in time, so time taken will be getting increased. And also, if you see carefully, I want to do it in place. So why the heck I would be requiring additional array, place all the elements in time, and then shorting it. At the end, I'm gonna return implicitly what? Nums1 itself. So why this approach is bad is because here extra space is used, and I'm shorting again, which is wasteful since arrays are already shorted. If you can see here, already shorted in itself. Nums1 is already shorted 1, 2, 3. Nums2 is already shorted 2, 5, 6. So why to do it again and again? So that's the thing. So because of this, I should come up with some better approach. So because I know that this shorting, the array which is I desire is already sorted, so I can use this sorting property. How? Just think about it. So what I can do is that if it is both arrays are already sorted, I can merge. I want to do what? Merge sorted array. So why not merge like in merge sort? I can do it. Correct. So the idea is what? What I'm doing is that I'll be saying, bro, I'll be taking 2 pointers. Let's say I and j pointing to nums1 and nums2, and I'll be comparing elements that we usually does, and then I'll be getting the result. That's what I does in the merge sort. But here again, if we see carefully, there's a problem. And what that problem is, that again I need extra array over here, which should not be the case. I would be requiring additional array again over in this case for this merge short as well. So if I'm using additional space, so the complexity also increase, that is a big O of m plus n, which is not a good thing. Again, there's a space complexity. Even if I remove this um, internal sorting, but merge sorting also will be requiring time, and also still, even after considering sorting property, merge sort is basically popular for that. Still having complexities. So what's the approach, better approach, better than this that I can come up with? So I can also have a look what all things others have. Sorting I'm not able to do with this property. I can do it in place. So let's go with that. Let's try it out. What if I do something considering keeping in mind that there is in place constraint? Is there anything that I can come up with? Let's check it out. If it is, if there is anything that will be great for thing for us. So yeah, let's think for it. What I can do here, the key observation is what this array that is here. This is the array which I is here. If I see carefully, that is here in this array, what I is here, that is there is already extra space here, extra space here at the end. And because nums1 is the one which has getting returned implicitly in this, in the sense means this is the answer which my function will be taking. So there is extra space already, I can leverage it now. So for this, but how? So instead of merging all these elements from the front, there's already a vacant spaces at the back. Why not go from the back side? So what I'm saying is that instead of merging from front, I will do what? I will merge from back. That's the one thing that I can come up with. With this, what will happen that I would be requiring additional space. I'll be using nums1 itself, and using this sorting algorithm, using the sorting property, I can compare elements in order to place it at its right position where it has to be. So I can go with this property, that is the, I'll be doing what, merging it from the back. So what I will be doing is that I'll be start filling this thing, that is I'll be start filling my nums1 array, this, because at the end nums1 is my answer. So let's do it. Start filling all these elements which I've added here after all this operation performing. I'll be start filling nums1, but from where? From the end. That's what I'm going to do. How? Let's have a look into it. So for this, obviously it is more than one array. I would be requiring a comparison that, okay, let's say at the very first position, which element has to be there? Let's say I'm comparing, okay, let's say I can't actually see and read the entire array, because as a machine, I'm only looking at each element. So at the very first, what is there? 1. At the very first, what is there? 2. In nums1 and nums2. So what is the smaller one among this? 1. So 1 has to be at the very first position, obviously. And whether 2 has to be at the very next to it, we need to check it. We are again checking it from this 2, because this is already at the correct position. So 2 and 2. Okay, this is already at the correct position. Now I'll be checking what? 3. because this 1 and 2 is already at the position where it has to be. So here 2 and 3, which is smaller, 2. So instead of 3 at third place, what has to be there? 2 has to be here. So for doing all these things, are we requiring pointers? So let's figure it out that what all pointers are there that I'll be requiring. So let's have a look into it. So what's the pointers is that, let's say there is uh, I pointer. Let's say I is the pointer, which is what? Which is pointing to the uh, last element of the nums1. That is not 0, but the actual valid element. And valid element is what? Nums1 has valid elements what? How much? M. So last element will be what? M minus 1, because the indexation starts from 0. So I will be pointing to last element. Why? Because I'm doing all this thing from the back. I'm starting doing all this thing is what? From back. So what I'll be doing is here. I'll be having I pointing to what? Pointing to the M minus 1. That is the last valid element in nums1. And then same goes to J. That is what? That is pointing to the last element in nums2. And elements in nums2 is what? N. So last element will be what? N minus 1, because indexing starts from 0, 1, 2, 2. So n minus 1 is what? 3 minus 1. That is 2. So J will be pointing to the last. Why? Because I'm merging all this thing from the back. So J pointing last. And also, nums1 also at the same time is considered as the merged sorted array. That is our answer. So for that also, I would be keeping the exact pointer where the element is already sorted and it is at the place where it has to be. We'll look into it when we'll be doing it, then we'll understand what it is. Okay. So firstly, I'll be requiring that pointer. Let's say that pointer is K. And what's the last position? That is, what's this position? Last of the exa, because I'm merging from the back. What's the last one? The nums1. That is, the nums1 is considering as it has to be merged sorted array at the end in the future that I'm going to do. Is what? I don't know the last position because I only know the M and N. So last position of this is what? This is what? M plus N elements that it has. So because indexing starts from 0, so the last position of this will be M plus N minus 1, obviously. So let's keep that also under the consideration. So K is pointing to what? M plus N minus 1 over in this case. Okay. So we just have the pointers. Now, what's the logic that I'm going to perform along with using these pointers? Is that I'm going to perform something like, because I want to do everything from the back. So I just need to compare elements and see whether it is at the correct position. If it is not, then I'll just be placing it at the correct position. Just now we did it here. Really quick try run which I just show you. So means what I'm doing is that I'll be saying what here. Let's say I does have this thing. This is the array which I does have. Great. Now what I'm saying is this thing. That is, let's say I is here. Let's say I does have a I does have a J, I does have a K. Okay. So here let's say I is pointing to, because I'm moving from the last. So here I is pointing to the M minus 1. J is pointing to what? J is pointing to N minus 1. And K is pointing to what? K is pointing to M plus N minus 1. So yes, place all this thing at its correct positions. Okay. So now I'll be comparing from the back that we decided earlier. Okay. So at I, what is there? 3. At K, what is there? 6. Which one is bigger? Because I want to do everything from the back. I need to place the correct bigger element among all these things, because how you see carefully, if this m number of elements is in non-decreasing, it's in the ascending sorted order, then small elements will be here, small element, the last element will obviously be the greater than among all these num1 elements, and same goes to here as well. This last element is greater than among all these things. So among these two, 3 and 6, whichever is bigger, that has to be the last position. That's the exact position where it has to be correct. So among ith point element, that is 3, and among jth element, that is 6, which one is bigger? That is 6. Okay. So 6 has to be here. Correct. So what I'll be doing is that I'll be putting the bigger one here. That is in num sort at kth. So instead of 0, here what has to be there? It has to be 6. Great. I hope you're getting it what I'm trying to say. Now, here, the moment I'll be doing all these things. So here, let me do that stuff. Okay. So here at kth, here what element has to be there? It has to be 6. Correct. Now it is 6. Because 6 is done, now 6 is not under the consideration. So why to keep j pointer here itself? Now j pointer should point to the next element to it, because I'm moving from back, is right to left. So j will move from 6 to 5 now. So let me move that 5. Now I'm not moving I pointer because I haven't found the correct position for 3 yet. 3 from the nums1, because 3 could be at the nums2 as well, because as you can see 2, there is 2 same elements. Yeah, they're got the same element as well. So for that into the consideration. So the 3 element from the nums1, I haven't found the correct position yet for that. Great. So I'll be finding it. So I is what? 3. J is what? 5. Which one is bigger? J, that is 5. So now my only search space is what? This one. Because this is already done. This is at the place where it has to be. So my only search space is this. Now this is done. So K should not be pointing to this. K is what? Pointing to the last. K is now pointing to what? K is the last space. My consideration space which I'm considering, that's pointing to that. That is pointing to that. Okay. So now K is here. That is the potential place where my elements needs to get added over here. Now, so 5 is the bigger element. So 5 has to be here, because if you see carefully, among 3 is the very biggest element in this entire elements in nums, and 5 is the biggest element in this elements in nums2. So among this 3 and 5, whatever the biggest, that has to be at the kth place, because that's the very last place of the current considered space. So at this place, what it has to be? Not 0, but 5 has to be here. Great, no worries. So let me place it 5 over in this case. Something like this. Okay, now 5 is placed over here. Now K is done for this as well. Now K will be pointing to what? Elements less to it, left element. So K is pointing to now this. Now jth pointer for this is also done. This is also done. So now I'll be moving to the left. So now J is pointing to what? 2. Great. No worries. So now among ith element, that is 3, and jth element, that is 2, which one is bigger? That is 3. Now is ith done. Now 3 is the biggest element. Now my search space is only till here, kth, and k is pointing to the last place, potential place where my now biggest element has to be there among the existing elements. So here among 1, 2, 3, this ith pointed elements is the biggest, and among this one element itself is there, and that is the biggest one I'll be considering, because that's the only element I desire. So among I equals to 3 and j equals to 2, which one is bigger? That is 3. So at the place of k, what has to be there? 3. So let me update it. So here k should be pointed to what? 3 now. Great. And now because that place is done, now k will be moving back. Now because I is also done, this consider 3 is already has been considered. Now I'll be moving I. Great. No worries. Now because j is not moved because 2 is still under the consideration, I want to find a place for this 2 element 2 in nums 2 array. So yeah, among again this 2, I equals to 2 elements and j equals to 2 elements. Which one is bigger? So here I have to check what is nums of I bigger than nums of j. So here I'll be saying no, nums of I is not bigger than nums of j. So what I'll be saying what? So I'll be for the tiebreaker I'll be using the k j elements. So here this element I'll be placing at the kth position. That is what? Kth position is what in this case? Kth position is not this. So I checked what is nums of I is greater than nums of j. No, it's not. It's equals. So nums of j has to be placed at the place kth element. That is 3. So here what has to be there? 2. Great. Now it's done. Now j is pointing to where? Nowhere. And k is done. Now here it has to be here. Now what I need to do? All the elements from nums1, nums2 is done. I don't have elements. J is out of bound. It is pointing to -1 now, for which there is no element. There is no index itself because the very first index is 0. So what I'll be doing, because whatever the elements are left with is already sorted and smallest. Because if it is not smallest, then it will have got the exact place where it has to be. If it has left, then it's smallest and it is already sorted. I know from the start itself. So I can keep that as is. I'll be placing that as is. That means what? If I'll be placing that as if it's nums1 and if it is nums2, let's say this is nums2, then I'll be copying all these elements in nums1 as is, because I want at the end nums1 is the answer that I want to do. So means what the logic that I did is what? Let me write it down for you. So what I did here is what? Firstly, I did what? I compare. What did I compare? I compared that nums of 1, nums1 ith element and nums2 jth element. Okay, where the nums of y is greater than nums2, and what I did among this, whatever the bigger adders have, I kept the bigger one. I put the bigger one at nums of 1 because nums of 1 is the answer at the kth position. This is what I'm doing repeatedly over in this case. That's my logic which I did, which I performed over in this case, in this approach that is merging from back. Okay, we have got it. So, and with this, doing all this thing repeatedly, what I did is that after doing all these things, I moved backwards. That's a very important thing. Why backwards? I already explained. Because we are going to move merge from back approach. I keep on moving backwards. Something like this. Great. Uh, so that is what we do. We should do. And yeah, with this thing, I think that it solves a problem. Because if you'll see now, I haven't used any extra space. It's in place, so there is constant space complexity, and the only time I require is to iterate over m and n elements. That is m plus n. That is the big of m plus n. Let's firstly see whether it's actually correct. We are going in the correct action or not. So let's try to do this thing. Okay. Uh, let me do this thing. Okay, so let's say this is the thing we will be doing. Here I just have nums1 array, nums2 array, m and n. Great. So now what I did is that I was having the pointers. Firstly, I'll be keeping the pointers over in this case. What I want is that pointers. So let's create the pointers first. So what are the pointers I'll be requiring? The same thing I'm writing whatever I did over in this case earlier in the explanation, that is pointing to m minus 1, that is the last valid element of the nums1, and then j pointing to the n minus 1, that is the last element of the nums2, and then the k pointing to the um, last elements itself of the answer, that is m plus n minus 1. And then what I'm doing, performing the exact logic, this logic. I want to compare till what I need to move backwards. So till what? For that I would be requiring a while loop. While what? While uh, I is greater than equals to 0 and then j is greater than equals to 0. Till that point I'm going to do this thing. What thing I'm going to do is that I'll be checking if nums of 1, nums1 of I is greater than nums2 of j. If it is the case, what I'll be doing is that nums of 1, because nums of 1 is the answer array as well. In that only I need to do the in place operations. So nums of 1 pointed by the k pointer. Okay, in that place I'll be placing whatever my candidate item is, exact element which has to be, because nums1 is greater in this case. You see, so I'll be placing nums1 elements at the kth pointer, at the place pointed by the kth pointer. So nums of on I will be here, and then because I is done, now I'll need to move the pointer I backwards. Or if it is not the case, that means what? That means nums2 pointed by the j pointer is greater. So nums of 1, because nums of 1 is the answer. So at the kth pointer pointed by the k pointer, they place at the k, there has to be the element, exact element, candidate element, that the nums of 2j is now will be placed over there. And now j is done, so I need to move the j pointer as well to the backwards. And at both the cases, either way I am going to get the whether the ith pointed element or the jth pointed element has the candidate. In that place I'm going to say is what, in both the places at both times I need to move the k pointer backwards. So I need to write irrespective of whether it's in the f or else. Great, no worries. But as we see here, it can go outside. If it is nums2, then okay, nums1 is already having all the elements. But if it is nums2, let's say this is the nums2, I have to place all the elements in nums1, because nums1 is the answer. Whatever the elements left, because this is already shorted and this is the element smaller than whatever the place I have placed. If it would be a greater, then it would have been managed over here. If it hasn't been managed, that means it is at the correct position where it has to be. But in nums1, okay, that's what I'm going to do in this case. So that's what here I'm saying, what that is, if nums2 still has only talking about nums2 elements, what I'll be saying is what I'll be saying what, while j pointer is greater than or equals to 0 still, then I'll be saying what, same thing, that is the nums of 1 of k pointed by the k pointer is equals to nums2 pointed by the j pointer, something like this. And then yeah, j is done. Now k is also done. Then I need to move it to the backwards. This is what I want to do. I don't want to return anything because nums1 is the answer. So this is the code that should work. Let's try to run it, whether it's working or not, and see. Yeah, it has been accepted. And let's try to submit it, whether it's getting submitted or not, whether it's passed all the test cases, which it has to be. So yeah, now yeah, it has been submitted as well. So why this works? What's the core inside? So if you see carefully, I'm doing all this in what? Merging from what? Merging or moving it from backwards, from backside, from back. So if you merge from front, you overwrite elements in nums1 because as we see that it could be the case at the end, let's say move out of bound, it is already at the place. I can overwrite it. So there could be a data loss. And if you merge from back, just now, like which we did now, use empty space, that is safe because I'm not overriding the potential answers. And this is the key pattern. When what the pattern is, when the extra space is at end, I'll be filling it from the back. That is the pattern. And the if I'll be look in the complexity as well, it's not that great. It's not huge. So the complexity also is so less. You see, that is the for the time required is what is just big of m plus, and that is just for the iteration purpose. And the space required is what? Nothing. I did all this thing in constant space. I used nums1 itself. I haven't used any additional space. Okay, so that's the thing I can come up with. So is there any alternative way that I can think of? What if you didn't know about back merge? Then what I'll be doing is that I'll be copying nums1 and shifting to the right, then merge from front. But still, it's worse than the optimal. Yeah. So that this is the best way I can go with. So uh, there could be the cases. There could be the edge cases as well. If we can see here, um, carefully, that is here. Edge cases are very so much. It could be the very one element itself. There could be no elements. So if nums2 is empty, do nothing. Nums1 is already having the element which it has to be. That's a 1, 1. If nums1 is empty, just copy nums2 because I'm one and nums1 has the answer. That's it. So if all nums2 elements smaller, then go in front. If all nums2 element is larger, then go at end. That's the basic thing. That's the edge case which I does have. So yeah, at the end, I just want to let you know why we have learned and what we have learned, all these things. So the pattern over here which we have learned is what? Here the pattern. That's a very important thing which we have learned is here is what? Is that this is not just one problem that yeah we have solved this using with this approach and all those things, and that yeah we are done with that. No, there's not just one problem. You learned pattern. That's called as, let's say, reverse two pointer, and then I'm filling it from the back. That's the pattern which I'll study over here. When I should use it? Used when one array has extra buffer space. See you. And I need in place merge. In that case, is much more efficient. So let me write it down. When should it get used? It should be used when one array is there that has extra buffer space, and it needs to be done in with the in place merge and all the stuff. Then in that case I can go with this thing. So this is the what pattern I have learned over in this case. Yeah, code it yourself, try it and all those things, and you'll be good to go. And we'll look into another problem, another pattern, another thing that we're gonna study. So yeah, here was me, Deepak. Bye bye.